Eclipse.
Welcome back, kids, to lesson 4.4c. You're going to take a look at the chapter 4 review tests and see if we can't get these numbers correct. Linear functions, discrete and continuous domains, and some other things. Let's do it. Okay, this is problem number 1 on the review. Take a look at the graph, and we want to find the domain and range of this linear function. If you look at each of the plotted points, you can see that you're going to need to take a look at what is the ordered pair for each of these dots. Remembering that our domain is our x value and our range is our y value. Let's take a look at each of these plotted points and find out what is our x and y value. Remembering that our domain is x, range is y. Looking at this first point up here in the upper left hand side, we can see that our x is going to be -5 and our y is going to be 3. X being -5 and y being +3. Keep writing these. The next one down, which would be right here, we see our x is -4 and our y is 1. X is -4, I can write that out, and y is +1. The next one down is going to be x is -3 and y is -1. And then the last one's going to be x is -2 and y is -3. Now you have just figured out the domain and range of this linear function. This step in problem 3, you're going to look at this linear function and you're going to plug in the x value. And this is called an input-output table, and we'll figure out what the y values are. Plugging in the x value of -1 times 3, you're going to get a -3 minus 1 more, which equals -4. Okay, we'll put that over here. And if you plug in the 0, 0 times 3 would be 0 minus 1, which equals -1. Let's plug in 1. 1 times 3 is 3 minus 1 equals 2. And the last one, 2 times 3 is 6 minus 1 equals 5. Okay, on this problem, guys, this is number 5. You're going to have to graph what's on the table. I'm going to show you how to do that, and then we're going to decide whether this is a discrete or continuous representation. So let's take a look at the first of our x and y values. That's 0, 0. We'll plot that. That goes right there. Be as accurate as you can on the little graph that's on your sheet. The next one is going to be a graph of 1 on the x value and up 4. So we go over 1 and up 4. And my y value jumps are going 2 each. So it goes 2, then to 4. We place that there. The next one is 2 over on the x value and then up to 8. So over 2 and then up to 8. So that's 2, 4, 6, 8. And we plot that. And the next one is over to 3, jump 3 to the right, and then up to 12. That's 2, 4, 6, 8, 10, 12 up top. Okay, and the last one's over to 4, up 4, and then on the y value, vertically, you go up to 16. It's near the top here, so 2, 4, 6, 8, 10, 12, 14, and 16. And you can see my dots are a little bit off, but if we were to go ahead and put a line through it using your ruler, should be able to get something that's semi-straight here, and we can try to mess around with that, but it should be right on the mark. Okay, so yours will be accurate, but that is a line. These are a little bit off, but is it continuous or is it discrete? And let's think about it. If you look at the values there, you have hours and miles. Remember, you can have a partial mile, you can have a partial hour. Bits of time or lengths can be broken up to small, minute pieces, so that this is actually a continuous graph. Okay, if these were something like cups or bottles of water or bowling balls, you would not have a piece of one of those. You would have a whole amount. But this is time and length, so you can have partial pieces, so it's considered continuous. Okay, for this we're going to look at this table, and we are going to find out what is the linear equation for this using the x and y values. Y equals mx plus b. This is an important formula to use. We can plug things in and figure out what we don't know. So we're going to go ahead and find our slope, and our slope is the m in our equation here, and we're going to do the difference in y over the difference in x. I've written it out here, and I've taken these values. Here's our y values, here's our x values, and I put them into this math problem where we can go ahead and write it out. We can see that if we say minus 5 minus a minus 2, that's almost like adding 2 to a negative 5, so you end up with a minus 3. And then you can go ahead and do the same with the bottom, minus 2 minus minus 1, you end up with a minus 1. Okay, if you divide that over each other, minus 1 divided into a minus 3, then you actually get 3, and that'll actually be 3x, 3 over 1x. So this is your slope. Once you have your slope, you can go ahead and plug in a value. So we'll plug in y here, and we'll say minus 5 equals, we'll plug in our slope here, which was 3, and x value, we'll take the next x value, which is right here, we'll say minus 2, and plus b. We want to find our y-intercept. So we can go ahead and solve this now. And we say 3 times a minus 2 gives us a minus 6, and we rewrite this here as minus 5 equals minus 6 plus b, and we go ahead and add 6 to both sides, and we get 1 equals b. So we can see that our y-intercept is going to be at 1. So you guys can go ahead and plot these points on your graph, and make sure that you go ahead and use this equation, y equals mx plus b, and you'll get the linear equation of y equals 3x plus 1 for this table. Pretty cool tonight. That's what I saw. Woo! Number 12 on your math will ask you if this table is linear or non-linear. Something to notice here, if you see where I've had an arrow on the x values, they go up 1, 3, 5, 7, and that is at a regular increase of 2 at a time. But take a look at the y value side over here. 3, 1, 1, 3, this is not increasing or decreasing by a regular or constant interval. This means that this chart is considered non-linear. Okay, kids, get ready for your test tomorrow. You'll do just fine. If you are still a little confused, review this video again, and you'll get it. All right, see you tomorrow.